Welcome to the second lecture on module 1 of ocean structures and materials. In this lecture we will see the presentation outline for the second lecture on module 1. We will talk about fixed type of offshore platforms in this lecture. I will discuss types of gravity platforms, their construction and the structural actions, the jack-up rigs and then jacket type platforms in this presentation. When you look at the offshore installations in general, in the previous lecture we have seen a list of different kinds of offshore installation all over the world. In general, there are more than about 6,500 offshore installation around the world. They are spread in about 53 countries. These installations are built for varied applications. They are meant for drilling, preparing water or gas for injection into the reservoir, which we call as enhanced oil recovery. Some platforms are also constructed for processing the explored oil and gas from the reservoirs. Some of them are constructed for cleaning the produced water before it is disposed back in the sea, because that is one of the important requirement of environmental impact assessment studies carried out on offshore installations. There are platforms constructed for accommodation facilities which will house people or personnel on board who will be working on the exploration and drilling works. Let us look at the first type of fixed type platform, which we call as gravity based structure, briefly named as GBS. The material essentially used for constructing these kind of structures can be either concrete or steel. The picture you see here is a very famous gravity platform, which is Hibernia. Gravity platforms have a very specific design objective. They are essentially meant for production of oil from the reservoirs. If you look at the salient features of a gravity platform, they essentially consist of large reinforced concrete bottom mounted structures. Essentially these platforms uses their self weight to resist the environmental loads. That is why the name gravity base platform is given to them. These platforms are not attached to the bottom through the piles. They are essentially suitable up to a medium water depth of maximum 350 meters. Concrete gravity based structures are constructed with the base as a reinforced concrete structural system. The design of the base includes lot of void spaces, what we call them as caissons. They are provided for the structure to initiate natural buoyancy. This enables the structure to float to the field development location during installation. Once the location is reached, these void spaces are flooded on the sea floor. The topside modules are lifted and placed in position over the top of these caissons. The void spaces are then used as storage compartments for storing the explored crude oil. Sometimes they are also used to fill permanently iron ore ballast to maintain stability during operations. The picture you see here show three different schematic views of gravity based structures constructed in different parts of the world: Brent platform, Ninian platform and Moraine GBS. There is a commonness between all these three kinds of platforms. I want you to observe this commonness. All of them do have a caisson base at the bottom. These caisson bays are very large in diameter and size. They help them to float, and the void spaces in the caissons will help to store the crude oil on exploration. All of them have very large and comfortable deck topside activities. These platforms are very stable under lateral loads. Look at the common structural members of these kinds of platforms. They have all common operational systems like helideck, double deck system, housing quarters, flare booms, drilling rigs in almost all of them. You can also see these structures are very massive in size, and because of its weight, which we call as a colossal weight of this platform, they are installed in sea without any pile supports. They rest on the sea bed by its own self weight. That is why the name gravity base structure is given to these kinds of platforms. The picture you see here show other 3 varieties of gravity based platforms constructed in the world. Troll GB is a very famous platform which contains lot of caissons at the bottom. T300, which we call as a troll platform, and Dragon has a single tower with lot of caissons at the bottom, which have very common and similar topside facility. Of course, the limitation in depth cannot exceed up to 300 meters as far as these kinds of platforms are concerned. In the previous pictures you see that these platforms have caissons at the bottom which are supported by the steel skirts. Now, the fundamental question comes is, why do we need steel skirts when caissons are very large in size and volume, which can enable stability of the platform by its own self weight. Now, steel skirts are required to improve the foundation stability. They act as erosion resistant members of gravity based platforms. They assist in proper grouting of the caisson base to the sea floor. They also provide transverse resistance to the platform against sliding. In addition to steel skirts, some platforms also have steel dowels. The dowels are extended about 4 meters below the level of the steel skirts. They help to prevent damage to the steel skirts. Essentially, steel skirts improve foundation stability against sliding. Gravity based platforms have many salient merits in offshore drilling. They support large deck loads. They have a very high possible reuse of the material. The construction and testing of these kinds of platforms are generally completed even they are floated and towed to the site. So, there is a good amount of quality control in construction and inspection can be done before the platforms are actually installed in the site. They support large field of oil exploration. They are essentially useful if you have a long term production. On the other hand, if you have got large number of wells which are yielding oil at a very high yield rate, then gravity based structures are very good choice to support large number of wells. The one of the greatest advantage of this kind of structure is that they have a very large storage capacity. They are more tolerant to overloading and seawater exposure in comparison to steel jacket platforms, which we will see subsequently at the end of this lecture. Of course, gravity based structures have certain demerits as well. The cost increases exponentially with the increase in depth of these platforms. They also impose a very serious limitation. They cause what we call foundation settlement. Geotechnical problems are very specific and critical as far as GBS platforms are concerned. They are subjected to very high sea floor cover. They may require more reinforcing steel than the total steel that is required to construct a jacket structure. It means the cost of the structures are very high and the volume of steel being used in this is much larger than a steel structure by itself when we compare it with the jacket platforms. There are some advantages of gravity based platforms over jacket platforms. It has a greater safety for people to work on board and topside facilities. Towing to site with the deck is possible. It means this minimizes installation time and cost. It has a low maintenance cost because concrete if submerged in water, is understood to have lesser problems than the tough steel. It has got a very high and adjustable crude oil capacity, which comes from essentially the hollow void spaces in the caissons. It has a capability to support very large deck areas. Risers which are used for oil exploration are generally protected because they are placed inside the central shaft of these kinds of platforms. They also create possible access to the sea floor from the cell compartments in the foundation, which has got a very healthy monitoring system of these kinds of platforms. These are considered to be comparative advantages of gravity platform with respect to steel jacket platforms. Of course, both of these platforms are fixed type of offshore structures. Let us look at some specific problems associated with gravity based structures in terms of its geotechnical complications. The picture you see here show 4 different kinds of problems associated with GBS platforms. Sliding, if you do not have a proper installation of skirt piles and dowel rods, though the weight of the structure can be very high, still because of the sea floor's covering, the platform entirely can slide on the clayey bottom of the sea floor. So, sliding is one of the important parameter or problem associated with GBS platforms. Because of its very high colossal weight, sometimes it can result in what we call a bearing capacity failure. There can be a bearing capacity failure at a specific stress concentration created at the foundation level on the sea floor because of its massive colossal weight of the superstructure. Sometimes when there is a differential settlement happening on the sea bed because of its weight, can result in an action called rocking. This can damage the foundation system and the caissons of the platform very easily, and the extent of damage could be very severe also. As we all understand, when there is a water entrapment happening below the larger area of foundation of these platforms, it can result in what we call soil liquefaction. Once liquefaction occurs, it can cause a differential settlement to the caissons of the platform, which can be associated as a very serious geotechnical problem of gravity based structures. Here is a field example. From this photograph, you can very well see there are interesting many number of towers constructed, which are supported at the bottom by large number of caissons, which are essentially void spaces when they are floated. Then they can be either ballasted to achieve a specific draft, or the void spaces of these caissons can be also used to store crude oil which is explored from this platform. You can see one over here which is being floated from the offshore, one is very close to the shore which is getting floated now. Ladies and gentlemen, the example you see here is actually concrete gravity platforms at Ardine Point on the western coast of Scotland. It is been constructed between 1974 to 1978. The total structure weighs about 300,000 tons. It is a very massive colossal weight of the structure. At the time of construction, the Cormorant A which you see here was considered to be one of the largest oil production platform ever built during the time of 1978. It was a record at that time. The top side you see here, which is comprising of a deck of about 100 square meter area. It has got about 56 caissons at the bottom, which has got a storage capacity of 1 million barrels of oil in total. It is carried by 4 116 meter high towers. These towers are of about 116 meter high. Just to give a physical feeling for you, it is as good as about, let us say, 75 to 100 story building. Is a closer view of the platform. You can see here the caissons have been constructed and then they have been tugged off by the boat. The construction was undertaken in a dry basin, as you see here, before the platforms are floated out for completion. Now you can see the platform in position. Of course the deck is not yet installed. You can see the 4 towers, you can see the caissons, you can see the requisite draft. Now the platform is getting floated, is being towed by the tugboats to the side. You can see these are the tugboats on the front side, these are the tugboats on the rear side, which is actually towing the platform to the required site for installation. The second classified platform what we have in fixed type offshore structure is what we call a jack-up platform. Briefly they are called as jack-up rigs. Yes, you have clearly understood, rigs are nothing but structures used for exploration under sea or under soil. We have used common land based rigs for exploring water. It is the same principle at which the jack-up platforms also work. The photographs you see here are different kinds of jack-up rigs which has been shot by me in different locations. There is again a commonness between all these jack-up rigs you see here. I will get a closer view of this particular rig in the next slide. You can see essentially these rigs consist of legs which is a steel lattice tower. You can see these legs are all essentially steel lattice towers, all of them are similar. It has got a very large complicated topside deck which has got all facilities as similar to that of a gravity based structure. You can see a closer view of a jack-up rig which is Maersk's Giant. This is the top side. The red one what you see here is actually an index for us to understand this is the maximum water level. Now you can see the 3 lattice legs which is coming out from the tower. You can see an helipad which is being used for helicopter landing. You can see a very complicated topside facility which is being given or made available on this jack-up rig. Now the question comes, why these structural members or these kinds of platforms are called as jack-up rigs. This is a closer view of this rig. You can see these 3 lattice towers which we call them as legs of the jacket or of the jack-ups are installed. So these legs are protruded into the sea bed for better stability, and then the deck is jacked up above the sea water level to have an enough freeboard for operation. Some of the vital components of jack-up rigs are shown in this figure. For example, part number 1 what you see here is a derrick. This is what we call as a derrick of a jack-up rig. Part number 2 is nothing but the draw out works which are being used for oil exploration. 3 shows you the drill floor where you are going to do the drilling operation for this jack-up rig. 4 is of course a drill pipe which is not seen in this photograph very clearly. 5 is a drill string. 6 is a cantilever segment which can be extended out from the top side of the rig, and you can see here the drilling does not affect the top side moon pool facility of the rig at all. So the drilling platform or the drilling area gets extended from the rig and then the drilling takes place. The 7th component what you see here are the steel lattice towers which are otherwise called as legs of the jack-up rigs. 8 of course is the living quarters. You can see the complicated living units here where people live here who work on the rigs. 9 of course is the helipad facility for helicopter landing, and 10 is what you see here is the hull of the jack-up rig. And spud can is a specific vital component of a jack-up rig which is not seen in this photograph. It is hidden in water, but I will show you in the next slide how a spud can looks like. Let us quickly describe a jack-up rig and its vital components. The primary design objective of a jack-up rig is for exploratory drilling. Ladies and gentlemen, please catch this word. the jack-up rigs are not used for production drilling, they are used for only exploratory drilling. For example, you are yet to identify a reservoir which has got a good yield, you are trying for exploratory drilling. Instead of going for a permanent installation like a gravity based platform, people generally go for a semi permanent type, what we call as a jack-up rigs. That is why the name rig is associated with jack-up platforms. It is similar to a barge with a moving legs. Imagine a ship or a very large barge which has got a moving leg. So that is what we say as jack-up rigs. The rig is towed to the site and the legs are jacked down, engaging to the sea floor and raising the platform. Since the legs are jacked down and the platform is raised up, we call this as jack-up rigs. They are suitable for shallow water depths up to 140 meters, which are essentially used for exploration drilling only, not for production. So these platforms do not have storage capacity. There are salient advantages of these platforms. They are highly mobile, they are stable when elevated, they have a very low cost of operation and they are very efficient if you want to use it for exploratory drilling. Of course, they have lot of demerits. The operational characteristics of this platform depends on a specific weather windows where they are located. They are strictly restricted to shallow water depths only, they cannot operate in deeper waters. They are subjected to very high sea floors covering problems. A blowout, if happens during the exploratory drilling, can cause a complete collapse of the platform due to its soil liquefaction. Let us look at the working weather window at which a jack-up rig can successfully operate. Jack-up rig, though they are capable of operating in harsh environments, it can work up to wave heights of up to 24 meters. The wind speeds can even exceed 100 knots. For your information, 1 knot is approximately equal to 1.852 km an hour of speed. So 100 knots, you can always see what is the wind speed at which these platforms can remain operational. Of course, the limitation is they cannot exceed a depth of about 150 to 170 meters, they are meant for shallow waters only. There are three main components of a jack-up unit, namely the hull, the legs and the footing, and then the equipment. Of course, we have seen a detailed photograph and view of a hull and the equipment, and of course the lattice leg towers. We will focus on the footing design of it. Before that, let us see what are the operational characteristics of a jack-up rig. When a jack-up rig is floated to site, which is equivalent to a moving barge, the deck is located at the bottom, which floats, which is actually towed, with the legs are all kept on the upside position. So this is what the towing position is, it is arriving on location, then the legs are lowered. On the other hand, the deck is lifted up. As the deck is lifted up, it comes to a position, then it is preloaded and tested whether the legs have reached enough location and resistance in the sea floor, so that the legs can stay in position firmly. So it is preloaded. Once the preload test is completed, the deck is further lifted to have a very clear air gap during operation. What does it mean is, in case of operation, because of high tides, the waves should not interact with the plants and equipments present on board. Therefore, the deck is shifted upwards further to create a sufficient air gap for safe operation. Once it is installed with an air gap, now the jack-up rig is ready for encountering different environmental loads caused because of waves, because of current, and because of wind as well. So this is a schematic view of how a jack-up rig is actually towed to the site, installed, commissioned, and then made ready for exploratory drilling operations. As you see, foundation becomes a very important and vital component of this kind of platform. Spud can is a very important component of a jack-up rig. As we saw in the previous photograph, a typical jack-up rig has actually 3 set of lattice towers, what we call them as legs. Each leg is equipped with a shallow conical underside footing. We call this as a spud can. The photograph what you see here is a conical shaped component which is put or which is located at bottom of every leg. This is a typical lattice tower leg. So, the conical shaped spud can is located under every leg. This gets founded in soil, maybe stiff clay or sand. The depth of penetration of this conical portion is approximately varying from 1 to 2 meters. Once you do this kind of foundation arrangement for a leg, it requires a very high pull out force for extracting this from the foundation. If you look at the operational features in terms of its depth of a jack-up rig, initially in 60s jack-up rigs were used only up to depth of 30 meters, whereas in earlier 80s people have tried jack-up rigs till about 100 meters, whereas in late 80s and early 90s people have tested jack-up rigs successfully for a depth of about 170 meters as well. So, jack-up rigs have been used to a maximum depth of about 170 meters. Ladies and gentlemen, I want you to recollect a very important point, that these kinds of platforms are never meant for production drilling. They are meant only for exploratory drilling. Therefore, they are very highly economical, and you can see in many countries people hire jack-up rigs for exploratory drilling. You do not have to own a rig, you can hire them, do an exploration, try to find what are the possible oil reserve present in that site chosen by geologists. If they are successful, you can plan to go ahead and to build a platform. If you are unsuccessful, you can give away the rig back to the leased person, you can go for exploration in some other site. So, they are actually used in terms of exploratory drilling only. As I said, disasters can be caused to jack-up rigs during storm. Here is a photograph where the complete jack-up rig got capsized because of a storm weather. You can see a complicated topside, you can see here the 3 lattice legs, you can also see here the 3 lattice legs completely overtopped and fully capsized. So, a strong and severe storm weather can cause disasters to a jack-up rig. You may lose the whole facility under such kind of critical situations. The next type of platform, which is a fixed type platform, is what we see here. It is a jacket platform. Essentially it is made out of steel, therefore people call this as steel jacket structures. If you look at the component of a steel jacket platform, it has 2 main components, superstructure and the substructure. The superstructure is referred as topsides in the literature. It supports a deck which is fixed on a jacket structure. The topside consists essentially of different modules containing drilling equipment, production equipment, gas turbine facilities, generator units, pump sets, compressors, a flare stack, revolving cranes, survival aircraft, helipads, living quarters with hotel and catering facilities for personnel working on board. The total weight of a topside alone can be as high as 40,000 metric ton. Here is a typical photographs of a topside or of a complete steel jacket structure. This is an animated photograph which is generated from the computer software. Is a real line diagram of a typical jacket platform. Different components of a jacket structure are marked here. You can see an helipad here, you can see a flare boom which is essentially used for allowing the outlet of the flare gas coming during the drilling operation. You can have the transition piece which is seen here, which I will explain in the next successive slides. What is a transition piece? This is what we call as a crane pedestal. I will explain the component of a crane pedestal in the next slide. These are called riser guards or boat standing areas. This is what we call as a jacket structure. So, it looks like a assembly of different kinds of tubular steel members forming a jacket. So, we call this platform as a jacket platform. You can also see the jacket bracings on every plane of the jacket structure. This is what we call as a mud mat of a jacket platform. I will explain what is a mud mat in the successive slides. This is a schematic diagram generated in the computer software of a jacket platform for analysis. This is a line diagram of a real jacket platform. You can see the flare boom, you can see the cranes, the helipad, the living quarters, the jackets, the bracings, then the skirt piles, then the risers, the derrick, etc. So, closer view of animated model of a jacket platform. You can see the top side can be as complicated as can have offices for a TV room, auditorium, an administrative block, a control room, power generator units, transformer units, test burners, support vessels, rig helicopters, rig heliports, platform heliports, cabins for working, rig office, games room, rest rooms, decompression chambers, and so on. This is what we call as a flare tower or a flare stack. This is a rig tower which is used for drilling rigs. We can see the lines which is going down, these are all risers. In the next photograph you will see them in detail. These are all risers, these are umbilical cable. This is what we see, the blue line here is a jacket structure. These are all the bracings of a jacket structure, and so on. Jacket platforms are suitable to water depths up to 250 meters. Of course, the selection of depth depends on the wave climate of the site. For example, look at the North Sea can be suitable up to 200 meters because of its weather condition, whereas in Gulf of Mexico people have successfully installed jacket platforms up to a depth of about 300 meters. We saw in the last slides, in the last lecture, different list of jacket structures being installed in North America. The jacket surrounds the pile, holds the pile extension in position from the mud line to the deck substructure. It supports and protects the well conductors, the pumps, the sumps, risers, and hence the name jacket is given to this structure, because it is forming a protection for different appurtenances and equipments which are housed in this platform. The jacket legs also serve as a guide for driving the piles. Sometimes because of this reason people call jacket platforms as template structures also. Soil conditions suitable for jacket platforms, essentially it is usable for clay, suitable for clay because it needs penetrable material for driving the necessary piles. It cannot be done in case of hard rocks. The steel jacket platform is one of the fixed jacket type platform which is resting on the pile foundation and is one of the very common kind of fixed structure which is being existing and used worldwide. The substructure or jacket essentially is fabricated from steel welded pipes and then pinned to the sea floor with steel piles. Piles are driven through pile guides on the outer members of the jacket. Piles are thick steel pipes of diameter 1 to 2 meter, can penetrate as much as 100 meters into the seabed. The common maintenance practice which is done for jacket structures is a cathodic protection, because steel being embedded in water which is partially immersed in water always susceptible to severe corrosion, Therefore, people generally use corrosion protection by what we call as cathodic protection measures, which we will discuss this in later modules. It is a typical view line diagram showing all the vital components for steel jacket structure. You can see a crane and a flare boom, you can see a derrick, you can see the top side, you can see the deck legs, you can see the bracings, you can see the pipeline risers, you can see the mud mat, you can see the main piles which are shown in dotted here. You can also see the skirt piles. You can see what is called as a launch truss, which is being used to launch the platform. You can see the skirt piles, the skirt pile guides, the barge bumpers, the boat landing facility, etc. Let us look quickly the components of a jacket platform. It contains a helideck. Helideck is a raised level of a platform which is used for facilitating helicopter landing. Solar panels are also mounted just below the helideck to facilitate auxiliary power for the platform. Flare boom is a long truss that supports a vent or a flare line. Top side or a deck structure has upper part of the platform generally above the reach of highest wave height that houses most of the mechanical equipments used for production drilling. Remember, jacket platforms are meant for permanent installations, they are used for production drilling. The top side generally equips machineries related to process, mechanical, electrical, piping and instrumentation. It also houses in form of housing, doghouse, living quarters, workshops, battery rooms, etc. Jacket structure is part of the platform which supports the top side. It is essential in assembly of a steel jacket pipes. Jacket is a supporting frame of the platform. It is designed mainly for encountering lateral forces from the waves. Crane pedestal is a large structural tube that supports an offshore crane for lifting purposes. Crane pedestals also function as diesel storage tanks, since the diameter of these pedestals are very large and they can house large amount of fuel. Piles are one of the major structural member that are driven through the hollow leg tubes to embed the steel jackets below the seabed. The pile embodiment generally is governed by the capacity of the soil to withstand the platform loads. Pile also connects the jacket structure to the top side. Skirt piles are required when the soil is very weak and the existing number of piles formed the geometry is not adequate. Skirt piles are run closer to the main piles as a cluster of 2, 3 and 4 in numbers. They are actually in groups. Transition piece is a very important component which is a structural member which is in the form of a cone that links the top side with that of a jacket. It is a cone shaped design because it is preferred as the leg size of the top side are much smaller in diameter compared to that of the jacket legs. Conductors are long, hollow, straight or curved tubes that embed into the seabed through which drilling is performed. To support such long length of the tube, conductor framings are provided. Risers are long slender tubes that carry crude oil or partially processed oil to another location for further processing. Risers are generally clamped to the jacket legs. Boat landing, barge bumpers and riser guards are components of the platform which are required for berthing of supplying vessels. They are used to facilitate smooth berthing. Barge bumpers are equipped with shock cells which are mounted on each side of the boat landing to facilitate a reduced vessel impact on the jacket platform. Riser guard is another protective structure which is used to protect oil carrying risers from the accident impacts caused on the jacket platforms. Launch truss is a very important vital component used for installation of jacket structures. Sometimes jacket structures are very large and cannot be lifted even with large cranes. Permanent structures like launch truss are provided on one side of the jacket to facilitate the loading out to the barge. The jacket is designed for buoyancy. The jacket is launched in sea after reaching its destined position for natural appending and leveling. When the jacket is launched, it floats due to its buoyancy. The jacket legs are sequentially flooded to make it upright, which we call as appending. In next few lectures we will see the construction process involved in case of installation for jacket structure. Mud mat is a very important component, the bottommost framing of the platform that helps in stability against lateral forces. They are useful to create stability of the platform even before the piles are driven. It is similar to a large raft made out of timber. It helps the platform to sink deeper if the soil is too soft near the top layer of the seabed. Essential purpose of a mud mat is to provide adequate resistance to overturning during installation as well as in operation. Essentially, jacket platforms are meant for production. It is nothing but a steel framed tubular structure attached to the seabed with piles which are driven to the sea floor. Legs act as a guiding device or jacket for the piles, constructed in sections and transported to the site in pieces. The design lifetime for jacket platform varies from 10 to 25 years. There are a couple of advantages of jacket platforms. Supports large deck loads, may be constructed in sections and transported because installation then becomes easy and simple. Supports large field, long term production, it can support large number of wells. Piles result in good stability of the platform. It has got a very little effect from the sea floor scouring, whereas gravity based platforms are sensitive sea floor scouring. There are a couple of disadvantages for these kinds of platforms because the cost of this platform increases exponentially with depth. They have a very high initial and maintenance costs. They are not totally reusable. Steel structural members are extensively subjected to corrosion, which is a very serious problem, and therefore corrosion protection measures are to be adopted in the design stage itself. Thank you.